Welcome to Anatomy and Physiology.
Okay, so we're here back again. This is still chapter 2, part 2. Okay, molecules and compounds. We've kind of went over like what an atom really is, and ions, the idea of ions, and the idea of cations, right? And anions, or negative, and things like electrolytes, which are usually minerals, and also electrons, which are negative, and protons, which are positive, and neutrons, which are no charge, and how they balance out. Now we're getting into molecules and compounds. So when two atoms click together, remember ionic or covalent bonding, they form a molecule. Two identical atoms may bond. For example, one atom of oxygen may bond with another one. It's called O2, and then you end up with a molecule of oxygen. That's the pure oxygen that you have in a tank. It's kind of a bluish color, and you can condense it and keep it under pressure in a tank, and then you can breathe it, and it gets you really high. Actually, it's not really good for you in far high amounts, right? You get like really loopy and stuff like that, and it's also super explosive. So you don't want to be doing that around candles or cigarettes or whatever the hell. Okay, so here hydrogen will usually mix two hydrogen and one oxygen, click together, and those will make a compound, which is or basically an atom called a molecule called water, H2O. Okay. For example, when two atoms of hydrogen, there we go, right there. So compound, a substance that contains molecules formed by two or more different compounds are different things, right? A compound of, like this one, see, this the oxygen, so you have a molecule of oxygen and a molecule of two molecules of hydrogen click together, they make a compound called water, okay? Water, okay. Things about water. Water is very important. It's the universal solvent. More things dissolve in water. Water can dissolve more things than any acid. That's crazy, huh? Okay. Uses solvent, blah, 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 da, da, da. More things dissolve in it, okay? Water is a temperature regulator. It absorbs temperature great. If you're in the water, you radiate your body heat out into that water really fast. So they used to have people in the Baltic Sea or in the Adriatic Sea or the northern seas. If you fall in the water, you're going to last about 3 minutes in that cold water without protective gear. And then you die. Okay, because you have no heat. Your body can't maintain its metabolism that way. It can't maintain its chemical reactions because there's no heat. When you freeze enough, you're done. Now there's certain kinds of frogs that have like a antifreeze in them or something that they'll freeze pretty much solid. They have no heartbeat. They have no noticeable signs of life, and they can't bend. If you move one of their legs, it breaks. But if you wait until they warm up, they wake up and jump away. Kind of an amazing thing. Ideal lubricant. Water is a major component of mucus, and snot, and all the other things, and all the lubricating fluids, like synovial fluid between the joints, serous fluid around the lungs and around the heart and around the intestines, and mucus is a really good one too. Digestive fluids too. It helps dissolve and really like break things apart. So it's like think of a cracker. Okay, if you have a cracker and you had no, it's like people they say eat a bunch of crackers and try to whistle. You can't because you have to have a moist mouth in order to whistle. You can't do it. Okay, water is a ideal lubricant. It's chemical reactions. A lot of things necessary to break down carbohydrates during digestion. We just said that. Cerebrospinal fluids, so yeah, all everywhere around your body you need water. Water is about, depending on your age. Now they always say like, oh, it's 70%, just like the world. The Earth is about 70%, 72% water on the surface. Okay, the surface area is about 72% water. The rest of it's pieces of land. But it goes deep too, right? Now, what percentage of your body is water? If you're a baby and you're pretty well hydrated and well nutrients and all that stuff, you're about 80%. And it gets less as you get older. So around you're like when you're old, like geriatric, you could be 50, 60% maybe 40%. I don't know. There's a way to check that. It's called tenting. Okay, so you take your hand like this and you pinch up like this. And you're going to use this if you guys become medical assistants or LPNs or RNs or whatever. You're going to start checking people, and you're going to check on their hand or check on their wrist, and you're going to see like you can go like this, and you're going to see how fast it goes down. And it should go right down like that. Mine's a little bit actually. Let's see. See how like if it leaves a little like tent like that, like little like whatever, that means you're dehydrated. Now remember, old people too, because they have had no good oils made by their body because of protein problems and other lipid problems and other water problems, their skin gets very brittle and they can actually, you can just tear it right off. You don't do that. Okay. As a protective device, use a protective important source of cerebral spinal fluid. Okay, yeah, we make that. So that's good, right? Oxygen, O2. Two oxygen molecules click together, become O2. Right there, you see it right in the picture. Right there. So if I'm looking up here, I can see it too. Right, I'm looking right at it. So you have a molecule of oxygen. Look how they share these electrons out here because they want to be stable, right? And then there's hydrogen molecules, and then they bounce over and bonk bonk. So this is a little. What it'll do is this going to be like a video or something? What's it? Go to flash carbon, create a new deck. No, forget it. Okay, we're just going to go down here. Carbon dioxide, CO2, carbon, CO2. There's two oxygens. Carbon dioxide is a compound that consists of one carbon atom and two oxygen atoms. This is what your body creates when it burns sugars. Okay, so sugars are like the C6H12O6, which is glucose. Your body uses glucose. It has it in water. It goes through a process, the pyruvate cycle, the Krebs cycle, which we get into later, and it breaks it down and it makes an energy called ATP, adenosine triphosphate. But it needs the oxygen and it needs water in order to do this process. Okay, at the end, its byproducts are going to be CO2, H2O plus energy, okay, or heat in the form of energy, whatever. So those are going to be your byproducts, and you have to get rid of carbon dioxide. If carbon dioxide stays in your system too long, your blood becomes more acidic, okay? And when it becomes more acidic, it's more damaging to your system. We don't want that. We want to have things be very almost neutral, and we'll talk about that in just a second. Okay, chemistry is a study of matter. Matter is composed of elements. Each element is composed of millions of the same atoms, blah, 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 waka, waka, waka. You can read that. It's very good. Good. Chemical reactions. Oh, look. Hey, that's exactly what we were just talking about. Chemical reaction is a process by which the atoms of molecules or compounds, remember, molecule is the same things, right? Oxygen, oxygen. Compound would be like carbon and oxygen. So, like, here we have C6H12O6. That's a compound. Oxygen, O2, that's a molecule. Carbon dioxide, that's a compound. So they're all compounds. Now watch what happens with this. So the chemical reaction characterized. So C6H12O6, this is glucose, blood sugar. It has 6 carbons, 6 oxygens, and 12 hydrogens. That's what all the sugars, like when you eat a cracker, we talked about the cracker, right? It breaks it down with an enzyme called amylase into starches. Those starches become, eventually, those are just sugars, really complex sugars. Sucrose, table sugar, basically. That's one that we usually use, but it still has to be broken down as the simplest form, and that's as simple as we can get, is this one right here, the glucose. Okay, glucose plus oxygen, okay, and then you do some other stuff in there too. It gives you, this is like being equal sign, carbon dioxide and H2O plus energy. Okay, so there's a lot of other stuff that goes on in here, but this is the this is the basic formula of how you get the energy for each of your cells. Now notice your byproducts of this are carbon dioxide, which you breathe out, and O2, H2O, water, which you pee out, okay, if you're going to do enough of this. Glucose you got to eat. Oxygen you got to breathe in, right? CO2, breathing out. Okay, there you go. The rates of chemical reactions, how fast they occur. Okay, chemical substances called catalysts speed up the rate of chemical reaction. Remember before we talked about catalysts, how if you pour dye in here or sugar in here, it all settles on the bottom until I give a catalyst, which is shaking it or mixing it or something like that, makes it happen even more. Okay, you can even heat it up, it'll help that happen faster. The other thing, when proteins perform the role of a catalyst, they are called enzymes. Most chemical reactions, they don't really require one, but they work much better with them. So some things will happen eventually, but we want to happen quicker, right? Acids and bases. This is kind of the important part. We're going to start after this, so I want this to be a smaller piece. A normally functioning body, like yours, requires a balance between substances classified as acids and bases. Acid-base balance is important in the chemical reactions. They occur when substances in balance. Okay, good. Acids and bases. Okay. Check this one out. Okay. We recognize sour taste of an acid. Grapefruit juice, lemon juice, vinegar are all acids. Okay. Now, an alkaline we'll talk about in a minute, but check this out. Hydrochloric acid. This stuff can burn through metal. It can burn through wood. It can burn through your skin. Is made with hydrogen ions, hydrogen, and chloride, which your body makes from water and salt. Your body makes one of the strongest acids. It's crazy. Okay, hydrochloride dissociates or breaks apart into hydrogen and chloride for our purposes. Most hydrogen chloride, okay. This determines the acidity. So the hydrogen in a solution determines how acidic something is. Okay, a strong acid breaks apart completely into hydrogen and an anion chloride. Okay, found in the stomach. The strong acid vinegar acetate. Okay, bases. So we have acids and base. Acid or alkaline. Okay, so base is like soap. Yeah, that's a base. So to combine bases that contain hydroxyl, okay, hydroxyl ion, OH, oxygen and hydrogen, okay. Sodium hydroxide or sodium bicarbonate, okay. Sodium hydroxide here, sodium hydroxide ends up as sodium and a hydroxyl group. Now, neutralization of acids. What happens is if you take an acid and you give it a buffer, and you heard of bufferin, the aspirin, that's salicylic acid. That's what aspirin is. But it irritates the mucous membranes on the inside, so they put calcium with it, which is a buffer which reduces the acidity of that acid and makes it a little bit more useful. Okay, what makes an acid? What makes a base? It's gonna be so the hydroxyl bases here. Bases contain often hydroxyl groups. That's what your answer is on that one. And acids contain the hydrogen. Okay, up here. They see it. You can read that again. The pH scale. So the pH, do they have a pH scale here? Oh, they do. Okay. Measurement of the pH scale. The pH scale is the potential of hydrogen. That's what it means, little p, potential of hydrogen to do something. The pH ranges from 0, which is super acidic, alien blood, all the way to 14, which is well, like that's an alkali, and you can get a burn by either one. If you ever watch the movie Fight Club with Brad Pitt and Ed Norton, there's a point where where Brad Pitt kisses Ed Norton on the hand, makes it moist, and then he pours lye, which is a very, very strong alkaline, and it burns, and he gets a chemical burn. And then he pops something open and he pours it on there at the end to neutralize it, and that would have been vinegar. Okay, so the vinegar, the acid, and the base neutralize each other, and it becomes neutral, which is safe. Now, you can do this at home in a different way. You take a little bit of baking soda and a little bit of lemon juice or vinegar and put those together and it fizzes. And what that's doing is taking vinegar, which is an acid, and it's taking bicarbonate, which is an alkaline, and you mix them together to become neutral. Neutral, right in the middle of that whole system, is 7 on that pH scale. Okay? And we go blah, 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 reading the pH scale. So each number, so from 1 to 2, is tenfold on the pH scale. You can see here's a cool thing. Look at your blood pH should be 7.35 to 7.45. That's your pH of your blood. So 7 is exactly neutral. So it has to be a little bit alkaline. If it gets a little bit acidic from things like injury, lactic acid, like you've been lifting a lot or working out a lot and your muscles are sore and you don't feel so good and your muscles are tight, that's lactic acid. Your body wants to get rid of that and recycle it in the liver, okay? Or you're holding your breath, or you haven't been breathing, you're almost drowned, or you've been injured and you're not breathing very well. They put oxygen on you. That's why we always give oxygen in emergency situations, because we know that at least some way we can get that pH closer to normal, because if it goes too far one way or too far the other, you can go into a coma, and that's not good. You have an alkalonic incident or an acidotic, respiratory and metabolic acidosis and alkalosis. Those are very bad things, and we don't want to get into those. And that's good. That's how this applies. Okay, that kind of thing. So you can have patients eventually who are just, they're not doing well, and you're going to do blood gases maybe. Maybe you become a respiratory therapist. You can do blood gases. You're going to find out the pH of their blood. The pH of your blood is going to give you a lot of information, okay? Did you know antacids are used? So why antacids are used? Here we go. With ulcers often have excess stomach acid. Sometimes true. They also could have a decrease in the mucus that protects the stomach lining. They can also have problems with the mucous membrane. Now, this all has to do with stress and stuff like that. We won't get into this here. So, stomach acid, HCl, can be neutralized with a drug that contains a base. You don't even need a drug. You can use potatoes. You can use sodium bicarbonate. You can use any of those kind of things. You just put like plop, plop, fizz, fizz, or underneath it was Alka-Seltzer, which was alkaline fizzy stuff that you would drink down and it would neutralize the acid in your stomach. Okay. Not a great idea chronically. I mean, once in a while, fine. You should probably take enzymes instead or something. But if you have digestive problems like an ulcer or something like that, if you take this a long time and you're taking it all the time, all the proteins that you're eating are not breaking down because acid is essential to break down proteins into amino acids. And the next step, of course, is the pancreas later down in the gut, and it helps break those apart so you can make other stuff that you need. So if you don't, it's going to rot inside you, and proteins that are rotten are called putrid. And if you've ever smelled a dead thing, that's inside you. So don't do that, okay? There we go. I think we're going to stop with that one because we sum it up here. Chemical reactions are processed whereby one chemical substance is converted to a different chemical substance. Okay, the rate of chemical reaction being increased by a catalyst or enzyme, which is a protein. A normally functioning body requires a balance between acids and bases. Hydrogen ion concentration is measured by pH, potential of hydrogen. As hydrogen increases, pH decreases. As hydrogen decreases, pH increases. So usually if it's giving away hydrogen, it's becoming an acid. You're an acid, go away, right? Now, if it's coming back to base, right? That makes sense. Normal blood, 7.3 to 7.45, slightly alkaline. And when it falls, the person is said to be acidotic. When it falls above, it's alkalotic. Those can be very, very bad. What does pH measure? It measures the acidity or alkalinity of something, right? Why is that important to monitor patient's blood pH? Because they could die. More detailed than that, please, if you're answering a question on that. If you're looking at why it's important to monitor a patient's blood, it will give you some ideas of how their physiology is actually working. If their lung physiology isn't working very well, they're going to build up what's called carbonic acid, and that's going to make their blood more acidic. If they're not going to the bathroom, they're not peeing, they're not getting rid of urea and uric acid, you got to get rid of the acids, you're going to build that up in your system and you're going to become uremic, okay, or acidotic. That's metabolic acidosis. Okay, not good. What blood is, so here you go. What blood pH is indicative of acidosis or alkalosis? So anything below that 7.35, so 7.34 is alkalosis. What just happened?
T to monitor the patient's blood pH.
We don't want to do that. See, I don't like this thing because it just jumps around, and I hate it when it jumps around. Okay, so there we go. We're done. Now, that's going to end us on this one, too. This was Chapter 2, Part 2. Okay, pH mostly. Next one we're going to get into, you can look at energy, and we'll talk about the different forms of energy and all that kind of jazz, and we'll go into suspensions and things, and then basically that's the end of the chapter. So we're going to do Part 3 in a few minutes, or whenever. I mean, you might watch it tomorrow. So take your notes. Don't forget to have your book in front of you. When you're taking the quiz, don't forget to look at the other videos. Don't forget to subscribe to, because I do other videos on this, all this stuff. And this is just for the Fortis people, unless you have this same book, right? This is the Herlihy, Human Body and Health and Illness. I have the 5th edition, but it's almost the same as the 6th edition, okay? You guys take care. We'll talk to you on the rebound, and we'll see you. Let me find a way to get back. How do we get out of here? There we go. We'll see you later. Don't forget to subscribe. Don't forget to log in. Spend some time doing your discussion boards and your case studies. And remember, this is just a process of getting through it and understanding this stuff. We're putting a lot of stuff in there. Some of it's going to stick. Talk to you later. Bye. You can do this.